Hello everyone, welcome to the workshop and welcome to this video which is going to be all about repairing the BSA Bantam cylinder barrel. If you recall, the barrel went away for a rebore, and when it came back, two of the fins were broken. They'd been knocked off in transit, so we're going to have a go at reattaching them in this video. I'd just like to say I hope that you are all well, and I hope that you're enjoying the videos that I'm posting up to the channel. Subscription levels have gone up. We're over 200 now, so thank you very much to everyone for making that happen. If you're not subscribed to the channel and you enjoy what I do, please consider subscribing. It won't cost you a shilling, and yeah, it helps to grow the channel, so I hope that you'll consider that. Right, let's have a look at the cylinder barrel. Well, I think this is probably the best view that I could get with this camera. I hope that it's, yeah, I hope you can see reasonably well. As you can see, I've already been having a bit of a go here and here. I can't get in here. I tried the TIG welder and I was having problems. As Aid at AG suggested it might, the joints were cracking. Basically, as soon as the arc was off, the things were cracking. So even though I was preheating with a blowtorch and then trying to get the heat back on as soon as I finished welding to try and sustain a little bit of temperature, yeah, it was cracking in the post-gas phase. So yeah, that wasn't working, unfortunately. Plus I was having a little bit of an intermittent issue with the TIG welder. I'm not sure what's wrong with it. I had it repaired last year, and it's doing all kinds of craziness with the display. I don't know what's happening with it, quite frankly. But that isn't the reason why. I'm not blaming the machine. The reason why I couldn't weld it was because I couldn't weld it. I just, yeah, exactly as Aid had said, it was just cracking. So I thought, well, this isn't working. What we're going to do? So I had a go at it with the down and dirty flux cord MIG welder, and actually on a low setting I got a couple of joints on here that I think are passable. They will not win any awards at a welding award night, but yeah, I don't think any of my welding will, so we don't have to worry about that. But this one I've had a bit of a go at with a burr just to take some of the lumps and bumps out, and it's starting to look reasonably okay. As you can see on this side, there's still quite a bit to do. But structurally, I don't think it's going anywhere. It's just tacked at the edges because I can't get in the middle. And with the piece at the top here, I'm going to do exactly the same. I'm going to tack it at the edges, and I'm going to have a go at getting a bit of a tack here in the middle as well. Just to give it a bit of extra strength. Now, yeah, I think it's going to work. So I will give the barrel a bit of a spruce up with some high temperature paint once it's done. But I wasn't going to do that, to be honest, because I don't want to tarp this bike up at all. I don't want to bling it up at all. I wanted it to be exactly, you know, as it came. 60-year-old bike in, you know, mechanically sound, get her running. But I think if I just give this a bit of a blast with the high temperature paint, you know, it'll just disguise some of the welding. It won't look as though it's been tarted up too much, and I think we'll have a fairly reasonable repair. So I'll get set up, I'll get this piece clamped in, and then let's see if I can repeat this reasonable level of success with you guys watching. We'll give it a go anyway. So yeah, let me get that clamped up and we'll have a go. Alright, well, there's no escape now, is there? We've got to do it. I've got an engineer's clamp holding this thing in fairly tight. I've got masking tape, singed masking tape around the other jaw so that we don't damage our new reborn cylinder surface. And I've given it another quick going over with the grinding wheel, because this cast iron, it literally oxidizes before your very eyes, and yeah, we're reasonably clean, so here we go. I don't know how the welder will affect the camera, but we'll see. What you see is what you see. Here we go. Try and get a tack. Okay, let's do the other side. Well, as that guy at Chernobyl famously said, not good, not terrible. It's welded together. Just putting a little bit of preheat in to get that middle bit. I didn't show you this previously, but this has been my technique. This is just to warm it up a little bit first. I think if you're from the UK, you'll probably remember the Mr. Blobby show, and if you're not from the UK, then trust me, be thankful that you didn't have to watch it. Yeah, I think he's been in here tonight, because we've definitely got Mr. Blobby welding. Right, so we're going to get that middle bit, and I think that's where we'll call it. Now, whether the blow lamp actually had any effect or not, I don't know, but it was probably worth a try. Alright. Not beautiful. But welded. So a little bit of work, quite a lot of work with the rotary burr, and let me just get you a better view of what we've done. Well, it's far from pretty, but I think it's got it. I'm not entirely sure about the penetration of this centre weld on the bit of broken fin, but you know what? I don't think it's going anywhere. I think it's stuck. So we have successfully glued it with sparks, and yeah, I'll have a bit of a going over it with a rotary burr, and then when I'm getting somewhere near, I'll bring you back. If I have to go back at it with a welder once this has been ground down, then you know, fair enough. But I actually think that really putting more heat into it is probably not going to do it any good. So if I can avoid it, I'll avoid it. But I think once we've got it cleaned up, it should look all right. So let's crack on, and I'll bring you back. Well, here we go. I've been working on it with a pencil grinder and a small drill mounted grindstone just in these areas here where the access was good, and I don't think it looks too bad. Just plonk the cylinder head back on. I will give it a dusting of high temperature paint just to sort of take the shine off it and just sort of blend everything in and dull it down a little bit. And you know, I hope you'll agree that you know, doesn't look too bad really. It's a shame we've had to do this repair, but it's done now, and we can move forward. So I'll let you have a closer look at these repairs in a moment. But just before we do, I'd just like to have a quick chat, if I may, about this material that we've been working with. This this cast iron. You know, I'm quite interested in materials and how they work, and part of my day job involves materials and failure analysis in the aerospace industry. And although I don't work with cast iron per se, mostly aluminium and its alloys and titanium alloys, I'm quite interested in this material. And my best guess is it's grey cast iron, and the only real way to know for sure would be to, you know, chop a lump off and send it over to the materials lab and get them to have a look at it. And what they would do is they would etch the surface. It's called metallographic etching, and they use a chemical compound. With iron, they'd probably use something like Fry's reagent, which is a ferric chloride, an acidic compound. And what that does is it gets through any scale and sort of the polished effect of the material, and it gets down to the grain, and then they stick it under a scanning electron microscope and they have a look at it, and you know, they look at the grain structure, and then they corroborate that with destructive testing, tensile testing and that sort of thing, and they come up with a verdict of what the material is. But we don't have the luxury of doing that, obviously. But we can have a best guess, and yeah, I think it's grey cast iron, largely because it's used extensively in the auto industry, cylinder blocks and sort of stuff like that, quite often cast from grey cast iron. It's easy to manufacture, it's fairly cheap, it has good machinability, but the major drawback is, as we've seen, low impact resistance, low shock resistance, and the reason for that is the way it carries its carbon. And if you were to look at the grain structure through the microscope, you would see the carbon carried as graphite flakes, random deposits of graphite flakes. And if you look at this piece here, this broken piece, that's actually quite a good representation of what they look like. And you know, they're all over the place. It's like a teenager's bedroom in there. They're just in any old house. And that is the Achilles heel of grey cast iron, because each of these sort of ragged edges that are randomly dispersed are a fracture point waiting to happen. And you know, it gets a knock, and the shockwave goes through and separates the grain at one of these edges. So that's our grey cast iron. You know, perfectly adequate for the job that it's doing, but as we've seen, it does have a fairly major drawback in its shock resistance. Other types of iron that you might have heard of, if you're a steam engine enthusiast, you've probably heard of meonated iron, and that is iron that has had calcium added to the crucible prior to casting. And what that does is it takes these randomly distributed flakes, and it gives them a much more evenly distributed pattern in the grain structure. And obviously, if you haven't got all these edges randomly sort of going all over the place, you've got a much more evenly distributed grain structure. It's a lot stronger. It's a much tighter bond, and that has two effects. It reduces the tendency to fracture on impact, and it also increases the wear characteristics. You get a better wearing material, and if you're making something like a steam engine piston, you know, that's an ideal quality, really. And then another type of cast iron is spheroidal cast iron, and this is when you add magnesium into the crucible, and what that does is it grabs the carbon and it has a balling effect. So you basically get spheres of carbon occurring throughout the grain, and again, you know, they become quite evenly distributed, quite tightly packed, and obviously with a sphere you don't have a jagged edge at all, so you know, much less likely to crack, and again, good wear properties. So that is your spheroidal irons. So anyway, sorry about that. I hope I haven't bored you to tears banging on about materials, but I find it interesting. I don't know if you do, but yeah. Thanks for listening. That's all I can say. Let's have a look at the repair in a bit closer detail. So let's have a look at that repair in slightly closer detail. You can see the one that the previous keeper had done, or somebody in the past had done. It obviously broken quite badly there. It looks like it's cracked along here, and all that had gone as well. But I'm not going to touch that because that's all part of the history of it, really. And that's how the repair I've done turned out. I can get that a bit closer, actually. There you go. That's after a bit of a grind down, and I've left it a little bit proud on the lower cylinder, because you'll recall that these are the only areas holding that quite large piece of fin that broke off. But I think in profile it isn't terrible. Well, there we go, finished article. A light dusting of high temperature paint, and it's all sort of blended in quite nicely, really. You can just see the outline there of the repair, but there we go, magic, it's gone. You won't see it once the engine's reassembled. Moving around the sides, there are a couple of lumps and bumps here and there, but nothing sort of more really than on the rest of the casting. There's lumps and bumps here and there just from the casting process, so I think we got away with that, and that's the job finished. Next we'll move on to top end rebuild. I'm looking forward to doing that, and we'll make it look like an engine again.